First, we have a circuit with a gap between two wires. When we replace the gap with a conductor such as metal, the bulb lights up. But when we replace it with a plastic bottle, which is an insulator, the bulb stays off. What if we replace the gap with a silicon? The bulb stays off too. But when we heat up the silicon to a certain temperature, the bulb starts to light up. This is because silicon acts as an insulator under room temperature and a conductor when heats up. We call that a semiconductor.
In a conductor, atoms, such as copper, have only one valence electron. The force of attraction between the electron and the nucleus is weak, so it conducts electricity easily. Other good conductor materials are gold, silver, and aluminum. But in a silicon atom, which has 4 valence electrons, the force of attraction between valence electron and the nucleus are much stronger than copper atoms. Semiconductor materials such as silicon, germanium, and carbon are commonly used in our daily lives.
Let's talk about energy levels. Every shell of an atom has different energy levels. The conduction bands and valence bands of conductors are overlapping each other, which make them conduct electricity easier. So, what about semiconductor? Does it behave the same way? The gap between conduction bands and valence bands of a semiconductors are slightly wider than conductor, making the electron cannot move from valence band to conduction band easily. But when we supply enough heat energy to the electron, things become different. The electrons can be promoted to conduction band easier.
When voltage applied across a piece of intrinsic silicon, the free electrons thermally generated are free to move randomly in the crystal structure and tend to attract to the positive end. This is a movement we call electron current. Hole is left behind when electrons move to positive end. This is called the hole current. Conduction in semiconductors is considered to be the movement of electrons and movement of holes in the opposite direction.
There are two types of semiconductors, which is intrinsic semiconductors and extrinsic semiconductors. Intrinsic semiconductors are pure, while extrinsic semiconductors are doped with impurities, forming two more types, the p-type and n-type semiconductor. Let's talk about p-type first. The major carrier for p-type semiconductor are holes. To produce a p-type semiconductors, we need to increase the number of holes by adding trivalent impurities atom. Those are atoms with 3 valent electrons, such as boron, indium, and aluminium. Each impurities atom forms covalent bond with 4 adjacent silicon atoms. Since 4 electrons are needed, a hole is formed.
For n-type semiconductor, the major carrier are free electrons. Pentavalent atoms such as arsenic, phosphorus, and antimony are added. Instead of forming holes, more free electrons are produced when pentavalent atoms are bonded with silicon atoms.
La 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 la